Okay, this is the first part of section 2.2, polynomial functions of higher degree. So this one has actually quite a bit of information. We're going to go ahead and cut it into two videos as well. First thing you have is we have our graphs of polynomial functions are continuous with no breaks, gaps, or holes. Okay, so kind of like the ones we have right here on the bottom. It's important to note that piecewise functions are not going to fall into this category. Okay, they also have smooth rounded turns or curves. You're going to see the word turns in a later part of this video. So it's kind of like the wherever it's concave up or down, okay? And then we have these monomial functions, f of x equals x to the power of n, so there's nothing else coming after this. And these are also called power functions. So these are some of the ones we're going to base a lot of our graphs on, okay? So we have two cases here where these power functions are either even or odd. If it's even, okay, it's going to follow kind of like what the quadratic does. So y equals x squared is the one that we've already seen, and this one is a parabola that goes up on both sides. If this n is even, so 4, 2, 4, 6, 8, it's going to follow the same pattern. So here you kind of have a little sketch of y equals x to the fourth. Please note these are not drawn to scale. This actually intersects this same graph at 1, 1. I just kind of drew a quick sketch, but the idea is that both of the arrows, so both of the y values, are going to be going up on both sides, okay? And it's also important to note that if the function is even like so, so the degree here is an even number, the graph is also going to be even, which means it's symmetric over the y-axis or with respect to the y-axis. In general, as these numbers get bigger, so if it's like a 6 or an 8 or a 10, whatever that number is, this curve will get flatter and flatter to the x-axis here. So it kind of looks almost like a box shape, okay? If the function is odd, so if this degree is an odd number, like 1, 3, 5, 7, and so forth, then the graph is going to follow kind of like what the cubic function does. So I put it here as a reference so you can kind of see. And I'm just not very good at sketching these. I tried to draw the one after it, x to the fifth power, a little bit more correctly, where it does intersect at that 1, 1. But in general, you're going to see that the end behavior is what we like to call it. The arrows here are still going up on the right side and down on the left side. Okay. These graphs are also odd. So they're not just odd by degree, but they're odd with respect to the origin. So symmetric with respect to the origin, where if you turn it 180 degrees, it's unchanged and it looks the same. Okay, or you can do that double flip we talked about in the previous lesson. Okay, so just some things to take note of. We're going to go ahead and try to sketch some graphs. These are going to be very rough sketches, so they're not going to include zeros or anything like that. We're just trying to get the idea of what the graph might look like. Okay, so here we have three examples. It says sketch the graphs, no tables required. We have our first graph, f of x is equal to negative x to the fifth power. So what I'm going to do is I'm going to use what I just saw up here, okay? And these are going to be small graphs. I'm not going to go too crazy on them. And I know that x to the fifth power is going to look like the one that's over here. So if I kind of want to do like a parent, okay, so x to the fifth power is kind of like this, okay, where you have the right side going up and the left side going down on this side. So if I make it negative, based on what I know about transformations, it's going to reflect across the x-axis. So that means that my new graph is going to flip over this way. So it's going to be something like that. Okay, so this purple one, this would be my f of x, or more a rough estimate of what it might look like. Okay. And that's pretty much it for that one. G of x is equal to x plus 5 to the fourth power. So now we have an even degree. So this is our degree here. It's an even number. So that means it's going to look more like the one that was up here. So more like this guy up here where both of the ends are going to be going up. Okay. So just like the one before, I'm going to go ahead and kind of do a wannabe, oh, get this a little bit straighter, a wannabe OG for this. So let's say we have our graph. My x to the fourth power is something like that. I know it's actually probably a little bit flatter to the x-axis here, okay? And then we have a transformation The transformation in this one looks like it's going to be going 5 units to the left. So 5 units over this way. Let's just say 5 is right here. Again, we're just kind of doing a rough sketch here. This vertex, so to speak, or this middle point is going to transfer over this way. So now my graph is going to probably be more centered around that -5, something like that. You're welcome to check all of these using your graphing calculator on your phone or Desmos. Okay, so that's a pretty decent sketch. And now we have letter C, which has a little bit more going on. Okay, this one is also an even function because of that 4. So this is also an even. I should have probably written that on top of all of them. We'll go back and do that right now. So this is also going to be even because of the number. We notice that it has 2 transformations. So, no, I cannot get this straight today. So I'm going to go ahead and take note of that. So again, since it's x to the 4th, my OG graph is something like that. Okay, something like that. And it's going to be 3 to the right. So let's say 3 is right here. 1, 2, 3, because of this 3 right here. And then it's going to be vertically compressed or have a vertical shrink by 1/3. So I'm going to make note of that just so we know. This one has a vertical shrink by 1/3, which means the graph is going to be kind of like squished this way. So it's going to look like it's a little bit wider. So just make sure that we do take note of these changes. So let's go ahead and use a different color. So maybe it's something like, I don't know, like this. Again, this is just a rough sketch of what it could look like, okay? So there we have it. Let me go ahead and go back and just make note of the changes we did for these. So this one was even because of the 4. We had a vertical shrink by 1/3. We also had 3 units to the right, so 3 units right, okay? In the second graph, we had a shift to the left, so this one was 5 units left, okay? And it was also even. And then our first graph was actually odd because of this 5. So this one was odd. And the only thing we have for this one was a reflection. So this one was a reflection over the x-axis. Okay, and that's pretty much it for these. These are not too bad. We're going to go ahead and look at some more uh, actual, not definitions exactly, but I guess kind of a guide on how to graph these. So we have a lot of stuff coming up. Okay, so let's go ahead and look at the top part here first. We have this thing called the leading coefficient test. Okay, so first of all, the leading coefficient is that number that's in the wavefront with our highest degree term. So if this was our function, f of x is equal to all of this, okay, we're going to assume that x to the nth is our degree of the function. It's the highest one, and this is in order, descending order. So this number, a sub n, this would be our leading coefficient. Okay, so this right here, that's our leading coefficient. So if you want to make a note of that, you can put it right here, a sub n. Okay, that's part of our title here. And what this does is tells us if the graph is going to rise or fall. So we have seen, maybe you've seen these notations right here, okay? It looks kind of weird, but what it means is, so if it's going to go up, so if it's up, you write something like this. F of x is approaching infinity. That's what this means. This means f of x approaches, I'm only going to write it once, okay? Infinity. Okay, that's what this one means, as, or y approaches infinity, okay? So remember, these are the two same thing. They're the same thing, f of x and y. And this would be a rise. So the graph is rising on that side. Or if it's going down, so if the graph is actually going towards the other end, so if it's going down, then that means f of x is approaching negative infinity, and this would be a fall. Okay, so that's what these notations mean. You're going to see them in the different cases that we have here, okay? So let's go ahead and I'm going to focus on one case at a time. Let's do case number one. Okay, let's do the top part first. So case number one, before I go into all this notation here, recall that n is the degree, okay? So the n that we keep talking about is the degree of the function. So if n is odd, so if that number is odd and the leading coefficient is positive, so the first number in front of the one in front of that is a positive number greater than 0, then the graph is going to have this kind of behavior where on the right side, so the right side, it's going up, so it's rising, and on the left side, it is going down, so it's falling. Remember, this means rise. This one right here means I'm not gonna write it every time, but this one means rise, and this one means fall because it's going to negative infinity. Okay, so let me kind of look at these notations here. On the right side, f of x, which is our y, is approaching infinity, so it's going up as x is approaching infinity. So as we go to the right, as we're moving, let me get a smaller pen for this. As we're moving to infinity on this x-axis, so think of it like, where my pen is moving. As we're moving this way, this graph is still going up. And that's what this means right here. On the other side, on the left side, f of x is going to negative infinity, so this guy is going down as x approaches negative infinity. So as we move this way on the x-axis to forever, negative forever, this graph is steadily going down. So that's what this means. That's what these notations mean. We have an example that goes with it. There's really nothing to add to this. I'm just going to kind of go over it. So for example, if f of x was equal to x cubed, okay, x to the third power, our degree would be 3. So remember, this is the degree. It comes from here. And a sub n would be equal to 1. So there's that imaginary 1 right here. We don't have to write, but we can put it there if we want. So this would be greater than 0, right? Which means it's positive. So since it's positive, it's going to follow this little pattern where on the right side, it's going up, and on the left side, it's falling. So rising on the right side, falling on the left side. And so if we wanted to describe it, we could say it like that, how I just said, or you could just write this right here. So on the right side, f of x is going to infinity as x is going to infinity. Left side, f of x is going to negative infinity, so it's falling, as x is approaching negative infinity. Okay, so that was case number one. Case number two. So let me go see if I can just focus on that one. So there's not too much going on the screen. Okay, so for this one, pretend that's not there. Our case number two is when the n is odd, so our degree is still odd, but the leading coefficient is negative. So if we think about this, if you make the number in front negative, all that's going to happen is it's gonna reflect, right? Reflect across the x-axis. So what's going to happen is the arrows that used to be here, now they're going to be in the other spot. So it just flips, okay? The right side is now going to negative infinity, so it's falling, okay, as x is going to infinity. So as we move this way to the positive side of x, the y is going down. On the left side, as we move to the negative side of x, so that's what this means, as x goes to negative infinity, the graph is going up. Okay, it is rising. We have an example for this one. I went ahead and added a negative 2 in the front, not added, but multiplied a negative 2 in the front, and our degree is still odd. So the degree is 5, and our a sub n is negative 2, which I don't have room here, but this is less than 0, okay, because it's negative. So if that happens, you can see that the graph is going the other way now, and our end behavior is exactly as we see it up here. Left side is going up, right side is going down. Okay, so not too bad. Third case, case number 3. So those two cases covered the odd. These are going to cover the evens. So what happens when our n is even? Okay, so the cool thing about even is the arrows go the same way. If it's positive, like if the first number in front, the leading coefficient is positive, both of them go up. So both f of x's are positive, see positive infinity, as x approaches either side. So the left side is it's going to the negative x's, it's still going up. As it's going to positive x to infinity, it is still going up. And we have an example that goes with that. F of x is equal to x to the power of 6. 6 is an even number, n equals 6, and a sub n, if this one is equal to 1, because again, you remember there's that 1 there. So it is positive, greater than 0. So you can see that both of them are going up. And if you remember from the previous page that we just went over, this is kind of like one of your power functions, right? So it's just going to be centered around the origin, and it just kind of gets wider and wider, flatter to the x-axis here. So yeah, both going up. Okay, that's it for that one. Last case, n is even, but now the leading coefficient is negative. I'm just going to get this all here. So all that happens is it flips. So instead of the arrows going up, now they're going down. So on the left side, you have f of x is going to negative infinity, so it's going down forever, it's falling as x approaches negative infinity. So as we go this way, it's going down. Same thing on the right side, except that now we're going to positive infinity for x. So we're moving the pen to the right side. The graph is still going down. For this one, I would include it kind of a more weird looking function just so you can kind of get the idea. So this one is f of x equals negative 3x squared times x minus 6 times x minus 4. And the degree is actually 4 because if you were to multiply this out, which I didn't, I mean I could have, but I didn't, you would have x squared times x, and that would be our highest degree. So it would be negative 3x to the 4th power. Okay, so that's why n is equal to 4 here. So in either case, it's still an even number. Our leading coefficient in this case is negative 3, so it is less than 0 this time, which means that the arrows have to go down, and we do have that right here, okay? The two arrows going down, and this graph looks kind of like an M if you were to graph it. We'll talk more about how to be able to do this in just a bit, okay? And those are the 4 different cases, which we are going to use in conjunction with one more type of, not test exactly, but process to be able to graph some stuff. Okay, but we'll get to that in a bit. Here's an example. Let me go ahead and move this up a little bit. It says describe the left and right hand behavior of each group. I'm sorry, each graph. Okay, can't understand my own handwriting of each graph. So we have 2 different examples here. Letter A is f of x equals 1/4 x minus 2x, x cubed minus 2x. Okay, so the first thing I'm going to do is identify what my n is and what my a sub n is. Remember, the n is the degree, and this is my leading coefficient. So the degree for this one, the highest one looks like it's going to be that 3. Okay, which means that this is going to be odd. It's going to be an odd number because 3 is an odd number. Not necessarily odd, like symmetric and all that, but it is an odd number, okay? They're only going to be symmetric if they're one of the power functions, like the ones we first saw. And then our a sub n is the leading coefficient. That's going to be 1/4, which is greater than 0. So this one is positive. So what I'm going to do here on the side, before I even try to graph this, okay, is I'm going to remind myself what that looks like. So I know that the odd ones are either going to be like this, so up and down this way, or up and down this way. Since it's positive, then it kind of follows the same pattern as my x cubed, so it's going to be something like that. Okay, and if you don't remember, you can always go back and look at your notes over here. Okay, so it's odd, so it has opposite end behaviors, and it's positive, so it's going to follow the right side up, left side down. Okay, so let me go ahead and just do a quick sketch of this, and then I'm going to go ahead and describe what's going on here. So again, I don't really know what this graph looks like. I'm just doing a sketch. I know it's some kind of cubic function, so it might look something like, I don't know, something like that. I don't know what the zeros are or anything, but I do know that it follows this pattern here, okay? So when I'm describing the left and right end behavior, I'm going to go ahead and do it like so. So for my left, okay, I'm going to say f of x, remember that's the function, is going to infinity because it's going up, it's rising, okay, as x approaches infinity. And for the right side, oh, I just meant to put right, but for the right side, so on this side, let me use a different color for that actually. So on this side, it's going down. So f of x is going to negative infinity as x is going to negative infinity. And that is pretty much it for this one, okay? So this is my answer, and there's my sketch to prove it, okay? Letter B, we have something that looks a little bit more complicated. It says f of x is equal to negative 3.6x to the fifth power plus 5x cubed minus 1. So for this one, I'm going to do the same thing. I'm going to identify what n is, and I'm going to identify what my a sub n is equal to. Okay. In this one, it looks like my highest degree is that 5. So this one is also going to be an odd number. And my a sub n is negative 3.6. which is less than 0. So this one is negative, okay? So just as a quick reminder for me here, I'm going to do my little arrow thingy here on the side. I know that it's odd, so it has to go in opposite, directions. And since it's negative, it's going to be the opposite of what I had over here. So it might be something like that, okay? Please take note that these don't necessarily have to be in these quadrants. I just do that out of habit. So this could actually be, they could actually both be on this side or on. So let's go ahead and try graphing this. Just a quick sketch. Okay, so since this is, I don't know what the zeros are, but I do know that it's going to follow that pattern. So it might look something like maybe, I don't know, something like that. And I'm just, like I said, I'm just mostly focused on what the end behavior is doing. What is this guy arrow doing? What is this arrow doing? Okay. I'm not worried about zeros or any of that quite yet. So for my left side, which is this one, it looks like it's going up. So I'm going to say f of x is going to, oh, I'm sorry, that's not my left side, is it? Let's correct that. My left side is, oh, I think I messed up here, didn't I? We'll go back and fix that one right now. So for my left side is, it is going up, so to infinity, as x is approaching negative infinity. Okay, and on my right side, okay, so that's this side over here, it's going down. So f of x is going to negative infinity as x is going to positive infinity. Okay, and that would be my answer for this one. So I'm just catching mistakes, guys. This is another weekend of mistakes. Let's go back to this one just very quickly. I just labeled them incorrectly. So this one, as f of x is going to infinity, as x is going to the positive side, this would be the right side, right? Because that's the right side of the graph. So just make that correction. This is the right side, and I do apologize about that, which makes this the left side. Okay, so just again, on the right side, it's going up, so that's why this is positive. On the left side, it's going down. That's why this one is negative right here. Okay. All right. Hopefully, I didn't confuse too many people with that. If I did ask questions in class, I can definitely do. These are really easy to do. We can do a bunch if we need to. Last part of this video, then we'll move on. We'll do the next video in a separate section here. Real zeros of polynomial functions. So we're going to talk about how to find those zeros that I was mentioning earlier. We have a couple things here that we need to take note of. The function f of x, or f, has at most n real zeros. That means if we have x to the power of 5, it's only going to have at most 5 zeros. So it's not going to cross the x-axis more than 5 times. Okay. Secondly, the function f has at most n minus 1 turning points. So the turning point is kind of like those curves I mentioned in the way beginning. It's like the concavities where we have different concavities. It's always going to have one less than the degree. So we have a quick example. Again, I don't really know what this one looks like, but I know I can kind of sketch a rough draft of it. Okay. So what I'm going to do here is identify my n. Since both of these deal with n, you want to figure out what your n is. So in this one, it looks like it's going to be that 4. Remember, it's the highest exponent when this is in order. And since n is 4, n minus 1 would be equal to 3 because 4 minus 1 is 3. So this means that I should have 3 turning points, okay, and no more than 4 zeros, okay? So I believe this one might actually have something that's called a double root, but I'm not quite sure. I'm going to add a couple more things. I see that my a sub n is equal to -2. This is kind of extra just for me, this number right here, which is less than 0. So that means that the graph is going to follow this format. Okay, this is from the previous page. If it's even, remember my n is even, then both of the arrows go the same way, either up or down, but since it's negative, it's going to go down. Okay, so I'm going to kind of just guess and say that this one does something like, I don't know, something like that maybe. Or I think, I'm not sure if this was probably in the center, but this is a decent sketch of what the graph might look like. It has the 3 turning points, so let me go ahead and circle those. So there's one turning point, there's another, and there's another. This is probably centered at the middle, so if you want to be sure, you can just graph it. And it has, let's see, 1, 2, 3, 4. No more than 4 zeros. Okay, so we are good to go. As long as you do qualify for whatever they're asking you, this could vary. Okay, just make sure that it does have the general shape. When we actually start finding zeros, which is coming up very soon, then that's when we have to be a little bit more specific. Okay, all right. So let's look at some equivalent statements concerning these real zeros that we're talking about of polynomials. Couple things here. X equals a is a 0. So that if you have something in this format, that's going when you're solving, that would be one of your zeros. X equals a is a solution. So these two are the same thing. A solution and a 0 are the same thing. Sometimes we write this as f of x equals 0 at this point. Okay, so anywhere that this is true, these are true. X minus a is a factor. You'll remember this from when we do factoring. We have the factors, and I tell you, okay, now we got to set this equal to 0. So don't confuse them. The factor is not equal to the solution. This is a factor. You still have to solve it to get to these two guys. Okay. And last but not least, a comma 0 is an x-intercept. So you have all these words. I kind of want to add one more just here on the side. A root is also a 0, because we have seen that word as well. Okay, so just some real basic stuff here. Last thing on this page, and that'll be it for this video, because believe it or not, but this notebook is done. So I'm gonna have to do a separate video anyway. Is we have repeated zeros. So repeated zeros are when you have a factor in this format, x minus a to the power of k. Let's say the k is equal to 2 or something, okay? When this happens, this is a repeated 0. And it happens often. It's like when you have like x plus 2 times x plus 2. It's the same factor. So, I mean, if you solve it twice, it's the same answer. When this happens, you have a multiplicity of whatever that number is. So for the example I just gave, x plus 2 times x plus 2, the multiplicity would be 2 because there are 2 of those parentheses. Okay? If k is odd and this happens, the graph crosses the x-axis at this point. So it doesn't really change it too much. It still kind of does the little S looking thing. Okay? If it's even, however, so if both arrows are going up or they're both going down, the graph is only going to touch the x-axis at that point. That's kind of what I was referring to here, because I think this one does have a multiplicity, so this point is probably just barely on the x-axis, but like I said, we hadn't got to that point yet. So just some things to remember. In the next video, we're going to go ahead and talk about how to find these and how to graph a little bit more accurately. So I'll be with you in a bit.